The electrophoretic display, or EPD, also known as e-ink, e-paper, ThinkInk. It's a display technology that uses very little power to create a high-contrast, reflective image. And it works by rearranging pigments using electrical fields. For example, this monochrome EPD consists of millions of tiny capsules containing positively charged black pigment and negatively charged white pigment between two conductive electrode layers, the top one being transparent. Applying a positive charge to the bottom electrode and a negative charge to the top pulls white pigment down and black pigment upward, creating a black appearance on the surface. And reversing those charges makes the surface appear white. By repeating this process over many points, we can display an image. Compared to other displays, EPDs go through a lengthy process to update their screen, physically repositioning millions of tiny particles each time. Those particles tend to stick once they're set in place. That's great for maintaining a static image without using power, but drawing that initial image will need to be done thoroughly. Let's look at the process step by step. First, the display draws an inverted version of the new image. Then, it toggles every pixel in unison from black to white, a total of 3 times. Then finally renders the new image. Lovely. That toggling sequence organizes the pigments. It's caused by alternating the polarity of the EPD's internal electrodes all at once. It clears out any remaining static charges and frees up any stuck pigments. Tricolor EPDs function using the same principle as their monochrome counterparts, but they need a lot more time to refresh because of that one extra pigment, which is usually red. And that pattern on the surface may look like separate pixels, but it's actually separate groups of pigments. The display's internal layer is divided into compartments, each containing negatively charged white, positively charged black, and positively charged red pigment of a larger particle size. Just like a monochrome EPD, black and white pigments are repositioned and displayed by applying charges to the top and bottom electrode layers. To display red, the EPD first displays the black pigment, with the larger, slow-moving red particles below. Then a charge of the opposite polarity is applied just long enough to pull the black pigment downward, but leaving red in the top visible position. Grayscale EPDs can display multiple levels of gray by mixing black and white pigments. They're basically monochrome EPDs with additional calibration, allowing them to control pigments with more precision and take advantage of e-ink's underlying analog nature. In addition to the standard monochrome positions, black and white pigments can be moved to specific intermediate levels by varying the voltage and duration of electrode charges. The amount of each color visible through the top layer determines the level of gray. And the variance in pigment position creates that slightly irregular analog aesthetic. The standard e-ink refresh is a thorough and visually jarring process, which inverts and redraws the entire display whenever any change is made to the image. But there are some EPDs that can be more selective. EPDs capable of partial updates can address specific areas of the display without requiring a full screen rewrite every time. And on top of that, they can skip the pixel inversion process and simply draw what changes between frames. This makes for a much improved viewing experience, but over time, partial updates can accumulate stuck pigments and show image ghosting. It's not a problem though, we can always run a classic refresh now and again to clean up. Of course, in order to really get to know a piece of hardware, you have to take it apart. The display is attached to the PCB using adhesive, which can be removed with some alcohol to reveal an inverted version of the display's image on the back. The ribbon connector and glass PCB are quite pretty with a little backlighting. Those thick gray bands are actually hundreds of individual traces used to control the TFT matrix. And after excavating some rubbery insulator, which excels at attracting hair, we can see the EPD's driver chip mounted directly on glass. Disassembling the display's film was a lot more difficult, and I ended up breaking it in half, which did work. Though I was expecting some sort of magical fluid, the main layer actually has a consistency of dried acrylic paint, which deserves a closer look. And by peeling that top layer back, we can see the face of those tiny thin film transistors driving each pixel. Hey little guys, sorry about those scratches.